the new lesson. In our previous lesson, we briefly introduced the tree data structure, which we said it widely represent the hierarchical data structures. And also we said that within the extent of our current lesson, we studied those three that have maximum of 2 children. So also we explained how to represent the tree data structure in programming, where we needed 2 classes, one class for our node and one class for the tree itself. Also we now know that our tree node, the node has 3 properties. One property was the data itself, and the other 2 properties were the pointers to the left child and right child. Also our tree class, it had only one property, and that was a pointer to the root node, or to the first node in the tree. Now when it comes to some operations like inserting new element, removing an element, deleting an element, or searching for an element, or traversing a binary tree or a tree, in order to do these operations, there are generally 2 approaches. These 2 approaches are the BFS, breadth first search, and DFS, deep first search. In breadth first search, we start traversing our tree level by level. For example, first we process this level, then we go to the second level. That means to this level, and then this level, and then this level, like level by level. First we finish the first level, then we finish processing the second level. However, in deep first search, we go as deep as possible, either from the right or left side, and then it's like we start processing from either left or right side, and we go processing as deep as possible. That we may learn about that in our next lesson. Right now I will focus on BFS, breadth first search. So in order to search a tree using the BFS, breadth first search method, we need a queue, and in a queue you already might know that the queue works based on first in first out approach. That means the first element added in the queue, that is processed first, and the last element added in the queue is processed the last one. So for that reason we use a queue. Let me implement that here, writing a program. So at this point we don't need these examples. So here we have our node class and we have our tree class, and inside the tree class I create a new method for BFS, breadth first search, traversal method. Let me name it also BFS. So in the BFS I said we need to have a queue, so I create a queue, const queue equals, and also you should know that when you are creating your queue, you initialize the queue with the root node, this dot root. However, one more thing, as a general note, you should know that whenever you are adding this root node in the queue, before adding this, once check, does it have a value or is it still a null? Because sometimes you may work on an empty tree, so if the tree is empty, you don't need to do any operations, just return null. So say if this tree does not, if this root does not exist, or it is null, just return null. Return null or return an empty set or whatever that you want to return when it is empty. However, when you have some node or some elements in the tree, So you start adding the nodes to the queue, and the first node that you add in the queue is the root node. Let me make a picture here, like how to uh, implement the breadth first search. Here we can follow the track, like how should we become sure that the first time the first level is processed, then we go to the next level, and then we go to the next level. And let me create a queue here. Let's say it is a queue that we start adding our nodes here in this queue. So yeah, like this. So now the first one, when you add the at this point when you add the root node, so let me add the root node here, and the root node is a. Let me add a in the list. So now we added a in the queue. So we say as far as this queue is not empty, we have to process the node which are inside this queue. So I'm saying while the queue dot length is greater than 0, you keep processing. And how do we process the elements from the queue? So uh, we extract the first node and process it. So const current equals queue dot shift. You know that if you want to extract or remove the first element from a queue, you use the shift method. So right now here we have only one element in our queue, and we removed that from the queue here. Now we process that. By processing that, I mean whenever you are searching your tree, you are looking for something specific. Maybe you are looking for some node having some specific value, and then when you are extracting those nodes from the queue, so you process that, you make like the compress, and you define a condition here, and whenever you find your like your goal node, so you say that, well, it was the node that we were looking for and we found at this point. And that is how we search our node. So here I removed this node from the queue. I removed this at this point. It is removed. So when it is removed, let me add them inside a list, keep track of visiting the node. I'm saying here const visit order equals empty set. So the way I am visiting or I am processing the nodes in the queue, I keep them here inside the visit order. So I'm saying that visit order dot push current dot value. So when we processed our current node, then for example at this point the current node means A. So when we processed the first node, then we add then we add its children. That means we go to the next level, and the next level means B and C, which are children of A. So now let's check this current node, which is A. Does it have any children? If current dot, for example, dot left or right, for example, let me check left first or right first, that doesn't matter. Say if current dot left, if it has a left child, that here we see it has a left child. So if it has, then add this to the queue dot push current dot left. Also, check its right child. Does it have a right child? So we say that if the removed node, which is A, current dot right, does it have the right child? If yes, so add this also to the queue. Push current dot right. So at this point, when we say add the current dot left to the queue, that means we added B in the queue. And at this point, we added C in the queue. So you know that first there we had A and we removed that here at this point. So now we added its children in the queue also. So again, when the loop continues, here it says, is q dot length greater than 0? Yes, now it is 2. So again, at this point, we remove the first node which is inserted in the queue. And which one is the first node? That is B. So now we remove B at this point using this shift method. The B is also removed. So when B is removed, we added B in the visited order also. And now we check, does this node B have children or not? If it has a left child, add this to the queue. Does it have a left child? Yes, we can see D is its left child. So added D in the queue also. And also this one we say, does it have the right child? We can see B has a right child also, E. So let's add this also in the queue. Okay, so now we added E also in the queue. So the loop continues. And here we say, is q dot length greater than 0? Yes, now it is 3. So again, we remove the first inserted node, which is C. At this point, when C is removed, and then C is processed, then we check, does it have a left child? Oh, here we see that C doesn't have a left child. Does it have a right child? We see, yes, it has the right child, and that is F. So then push or add it to the queue, okay? F is also added to the queue. And C, so at this point C was removed. At this point C was removed. We check its left child, it doesn't have the left child. And when we come here, it has a right child, which is F. Loop continues. So we say this time, is q dot length greater than 0? Yes, it is 3. So we remove D. And then we check, does this node have left child? No. Does it have right child? No. So the loop continues. Is the q dot length greater than 0? Yes, it is 2. So we remove the first inserted node, which is E. So when it is removed, we process this, and then we say, does it have left child or right child? We see that it doesn't have. We continue the process, the loop. At this time, when we say q dot length, is it greater than 0? Yes, it is 1. So we remove that node also. We remove this from the queue. Then we check, does it have left or right child? We see it doesn't have. At this time, when q dot length is checked, we see that now q is empty and the process stops. And we have kept the visit of our order here in this visit order array. It is how BFS works, that we check every node in the tree. I hope it was clear enough. And in the next lesson, I will explain how we work with DFS.